Hey everyone, so this is a series that I'm going to start in which I'll be implementing various foundational machine learning papers. The first paper that we're going to target is Attention is All You Need. The software on which I'll be coding it out is TensorTonic. It's a free software as of now, that's what I've known. So you can go through it. It's a very beautiful kind of software. The first process in Attention is All You Need. They have broken down into various chunks as to implement it along with various visualizations as well of the architecture. So the first step is tokenization. So getting a very brief theory about tokenization, as this series will mostly be implementation heavy or mostly the coding part of the tokenization of the papers and the architectures. So tokenization is a process of converting the raw text into sequence of discrete symbols that a neural network can process. It's a very first step in the process of any NLP pipeline, and it'll have the profound effect, as it's written, profound effect on every downstream task. Every task that uh, succeeds, tokenization will have an effect on the output data as to how clean, how better it is. In this lecture, we'll be coding out a word tokenizer. There can be various type of tokenizers as well. They can be character or whatever you want to tokenize. So it the visualization is also given. If you write anything, uh, it will provide the tokens as to how it would. The need of tokenization is to convert human readable text, human readable sentences, or human readable comprehension into machine readable form. So that's what our tokenizer here would do, as it's given here. The input is hello world, and whichever unique ID or tokens would be empty at the time, those tokens would be allotted to the unique words. If you would go through the theory of the process, this is the training level. These are the various process that's given in there. First, we have to build a vocabulary. Vocabulary would store each unique word and provide a token for it. Then we have special tokens. Padding token, which basically has the assigned ID as 0. These are null tokens, as you can say, or 0 tokens, which doesn't have any effect on the meaning or the semantic understanding of the text. They are just there to make the sequences in all batch of the equal length. The model would later on learn to ignore the padding positions, that it doesn't add any value to our model's understanding of the comprehension or the corpus of words we have. Using attention mechanism, or just by learning that padding carries or pad tokens carries no specific information. Then we have the unknown token, which will represent any word which will not be found in the vocabulary. That is, every new word would be an unknown word to our corpus of known words. Then we have BOS, that is beginning of sequence token, or SOS, as you say, start of sequence token, which will mark the start of every sequence, and similarly we have the end of sequence token, which would mark the end of every token. Then there's the encoding process, which is converting that particular string or a word into specific tokens for human readable form, for machine readable form, or basically giving it onto a neural network to perform the calculations and predict the value. Similarly, we have the decoding process, that is to convert the tokens or the embedded form back to human readable form for our understanding of the output that the model would give. Here, the complete tokenizer pipeline is also given. That first step is to add the special tokens, then split and collect the unique words, assign various IDs, encode that sentence, encode the unknown word back to the sentence, and decode the uh, output back of the uh, decode the output back into the human readable form. Then we have the outer vocabulary problem. That is, it cannot represent the words it has not seen during training. That is called the outer vocabulary problem. Basically, if you would throw a word at a tokenizer which it has not seen during the training, then it wouldn't have any specific mapping provided to it, and it'll just be an unknown token, unknown word with respect to our model. So we will also tackle that in our issue. We'll provide an uh, for loop to go through it. Then these are various level tokens, server tokenization, that is byte pair encoding. Usually byte pair encoding is the one that is used. And you can go through the theory here further. We would be further, I don't remember, but I guess we would be further going in the embedding connections as well, that is tokenizing it into integers and then encoding those integers into embedded form, embedded into an embedded matrix. Okay, so what I have done, as also given in the question, that we have three functions, that is build vocab, the encode function, and similarly the decode function. What I have done is broken down all three of them in separate processes. So this is the first function, which is build vocab. First step, first let me walk you through this flowchart, and then we'll go back to the coding part. Training, we have the training test, and then from that we'll create the build vocab function. The first thing that we would proceed with is initializing an empty word to id and id to word variables, self instance variables, which will in future help in creating mapping between string and integer tokens and reverse mapping of integer to string tokens. Then we would add the padding unknown BOS in US tokens. We would assign fixed IDs to special tokens. That is, uh, we will provide new unique indexes to the upcoming words as we'll keep on encountering them. And then finally, we would iterate over each training sentence that has been given to us in the training from the training corpus. Then we will split the sentences into words, and then we would check if the word is present in the vocabulary. If yes, then we would skip the word as it has already been provided with a unique ID, so we wouldn't have to change it. If no, then we would assign a new ID to the word and we would update the vocab size. That is the total corpus of the new updated vocabulary that we have up till now. So let's code it out, and then we'll move on to the encoder and decoder. Okay, so this is just a constructor function. This is just a constructor. This variable would be used to map the words to integers. The id to word will be used to provide the reverse mapping. Vocab size would be used to store the total number of tokens that we have encountered up till now, and these are the special tokens: padding, unknown, BOS, and EOS. The first function that we have is build vocab function, where I have to build a vocabulary from a list of texts. This would be our training data that we would use and provide each sequence. And we would add the special tokens first and then the unique words. That is, we'll first have to create a list for the special tokens, and then we would move on to the unique words and provide them with the new unique IDs with every turn. So first let's get to the creating a list. Okay, so first we'll create the list for word to ID and ID to word, and then we would create a list of the special tokens. uh, self dot padding token. Then we have the unknown token. Then we have the POS token, and then we have the end of statement token. Then what we would do is we would iterate through every index and every token in our special tokens and check if that word has already been encountered, and then we would find the index of that particular sequence in our special tokens word. I mean, if we are getting the special tokens word, special token sequence, then and if we are finding the length of our special tokens list, then that would mark the end of that particular sequence, because last token would already be EOS, that is end of sequence token, and that index we would use later on into finding out that we have separate sequences of text or sentences. So when we would convert it back to human readable form, then we would have those particular indexes from starting till end, and we would have particular sentences given out as output in human readable form. So for every index and token in our special tokens, what we would do is create a mapping self.word to id from the token to the id. Sorry, it's a bit of C++. Then we have id to word. We will find the index and provide it as word, not word but token. Yeah, token. Okay, and then we would find the length of the special tokens. Then finally we would go through our corpus, go through our training data, and we would split. Let me show you. For text in text, we would go through every word. That is, we would go through for word in text. Okay, so for text in text means we are taking particular sequences, and after taking the sequences in the next loop, what we are doing is we are finding every word in the word present in that particular sequence. What we can do is use strip function to strip it of all the leading useless characters and white spaces. Then we would split yeah, then we would split it to get it out of the, we would get it devoid of any white space, and we would treat it as a single unit, as an atomic value for our tokenization. Then we would create the mapping for this self dot word to id, that would be equal to the index, and a self dot id to word, that would be equal to the word that we have encountered. Now what this will do, um, firstly we have treated the special tokens as given in the question. Then we are going through the unique words and providing them with specific indexes or IDs. Now what we would do is we would increment the index by 1, so that whenever we would encounter a new unique variable, then it will be provided by the next unique index, that is like if you would run if you would do a rough run, then if an particular ID, let's say if an ID 34 has been provided to a number, provided to a word, then when the loop would iterate again and it would encounter a new unique variable, a new unique word, then it would provide it with 35. That's what I'm saying. Okay, so after that we would just increase our vocab size. That is, we will update it with the new value of index that we have encountered. That is the new length of the sequence, and that would be it of our building vocab function, which was the lengthiest one. We would just need to write the smaller code for encoding and decoding. For encoding, we would provide the input text that we have been given in the question, and then we would encode it and we would pass it through the encode function. What the encode function would do is split that text into words, similarly to what we have done right here in the build vocab function. If the word would already be in the vocabulary, then it would if the word has already been in the vocabulary, then it would map the word to the ID. But if it is not in the vocab, it's not in our vocabulary, then it would map it to unknown ID. Then the unknown ID would go back into the build vocab function and it would get assigned to a new unique ID, and then it would come again back into the encoding function, and then it would pass through the yes, that uh, word then would be mapped to that ID. Then we would in both the conditions, then we would append that ID to a token list that we will create, and finally we would return that ID list, and that would be that complete list would be a sequence of uh, unique IDs that we have been that we took out from our sequence of human readable words. So if we would write the code for this, first we would create a tokens list. Then for every word in text, uh, in text dot strip dot split, we would um, we would assign a token ID. For every word, we would assign a token ID. Self dot word ID dot get. We would use the get function to fetch that particular word from our corpus. If we would find the word, then we would just map the word to that ID. But if we wouldn't find the word, then we would map it to the unknown token. No, but then we would need to provide it with a uh, word to ID mapping function. That is word to ID. Yeah, okay. Then we would send it as an unknown token to our word to ID variable, and it would convert it into a variable. It would convert it into a word that already has an ID within our corpus. After creating that mapping, we would just append it in our list. Then we would just return our tokens. Similarly, we have the tokens ID right now. After encoding all of them, then we would pass on to the decoding function, iterate over each ID, and if the ID is in the vocabulary, then we would map the ID to the word. If it is not in the vocabulary, then we would just mark it unknown. Now in decoding, we would not try to convert it back into a human readable form because we have never encountered that particular word in the training data. So that would remain as an unknown token, and we wouldn't know the meaning behind that set of digits. Then we would just append the word in our words list. We would join the words into a string so that it's proper meaningful sentence, and then we would provide it as a decoded human readable text. Code is mostly similar. So we would here create a words list for every index in IDs. Um, Word would be self.id to word. We will use a get function. Then we would find the index. We would find the index. If we would not find the index, then we would replace it with an unknown token. Then we would append it into our list of word, and then we would just join it. We would just return it as we would need to give the white spaces now, and we would just join the words, and that would mark the completion of a tokenizer. Okay, we have an error. Hmm. Okay, so you are encountering a simple syntax issue. Uh, hmm. Yeah, is an underscore missing. Uh, okay, we again have an issue somewhere here. Huh, here it should be self. Thing it should run now. Okay, there is no attribute as get, so we have to use get differently. Uh, should we use? Shouldn't we use get here? Let's try this. I think this would take time. Let me just go through the code once again. Okay, finally I was able to figure out the bug. Uh, One major issue that we were doing was we weren't writing the loop if we would encounter an if we would encounter that that particular word is not present in our corpus. We would just have to add a single line, and that may be able to make our code go fine. Here we would have to create another for loop for another if condition if word not in text dot strip dot split, then it would have to, let's try to run it out. Okay, it should also be, yeah, let's run it. Hmm. So the code is working fine, but we are encountering some other issue. Let's go through our previous submissions. What mistake that we may be doing? Okay, Hmm. We're not creating a mapping. Keyword. Here would be an index. Now it wouldn't go out of vocabulary. But again, that's not the issue. Hmm. Then here we have the unknown tokens. We are creating the tokens. We're appending the token IDs. We're appending the token IDs. Then we have the words. Creating the index ID for words. We have this. We're creating self unknown tokens. Words sort of append join. We're creating the join. Hmm. Hmm. Mhm. Here we're providing the word. Here we're providing an ID. Self word. Okay. If okay, this is a mistake that we're doing. If the word is not present in the self word, we after checking in the training sentence, we're again checking in the training sentence. Would have to self word to ID. Okay, we were not checking in our already made up vocabulary. Okay, this would mark the end of this tokenizer. Would push this particular code in GitHub repo and would upload it in the um, description, and I would also provide the this flow diagram for your reference. Okay, thank you.